Hello everyone, welcome to the next video of our channel Solutions from the Book from the series 100 Problems Around the World. Today we will take a look at Italy Math Olympiad of 2023, their final phase who was held where they always do it in Cesenatico. It is the national phase, let's say, of Italy, the national stage, and the problem we have selected for today is as follows. Let a and b be positive integers such that 54 to the power of a is equal to a to the power of b. Prove that a is a power of 54. So, if you have any idea how to solve this problem, as you already know the drill, please write it down in the comments. If not, let's take a look at the solution together. So we have covered the solution so we can go through it step by step together, and let's start with the reasoning we can do on such a problem. Initially, we are given that these AB positive integers are such that they fulfill this condition, and we're asked to prove that A is a power of 54. Now, first of all, let's see that 54 is actually equal to 27 times 2, or 2 times 3 to the third. So this means that A divides the number 54, because 54 in the power A divided by A from this equation over here is equal to A in the power of b minus 1, which is, let's say, a natural number. So a should divide 54 to the power a. And in order to do so, given that 54 has only 2 and 3 in its prime numbers, let's say, representation, a should also have and only 2 and 3s as prime factors of its prime representation. So we'll get that a is of the form 2 to the power x times 3 to the power epsilon for some x and epsilon from the set of natural numbers. Now this is a very important result that we will now use in order to prove the claim that we have in this problem. So the given condition that 54 to the power a is equal to a to the power b becomes that 2 times 3 to the third, all of it in the power 2 to the power x and 3 to the power epsilon. So it can be represented, as we said, as 2 times 3 to the third, all of it in the power 2 to the power x and 3 to the power epsilon, which is equal in this case that a can be expressed, as we said, as 2 to the power x times 3 to the power epsilon, all of it in the power b. So we have substituted the value of a in both sides of this given equation. Now, if we do some simple calculations on both sides, we will get that 2 to the power x times 3 to the power epsilon times 3 to the power 3 times 2 to the power x times 3 to the power epsilon is equal to 2 to the power xb times 3 to the power epsilon b. So we can now, in the equation number 1, compare the exponents on both sides for both factors, because in order to have parity, the exponents of these prime factors should be equal to each other. So we'll get that 2 to the power x times 3 to the power epsilon should be equal to xb, and 3 times 2 to the power x times 3 to the power epsilon should be equal to epsilon b. So this is another equation and another form of the given initial condition. Now from the equation number 2, we can directly say that epsilon is equal to 3x, because we see that these expressions over here are equal, and the difference between xb and epsilon b is that epsilon b is 3 times bigger than xb. So by simplifying b on both sides, we will get that epsilon is equal to 3x. Now, by making this substitution in the form that we deducted up here of a, we will get that a is of the form 2 to the power x times 3 to the power epsilon. Substituting epsilon equal to 3x, we will get that a is equal to 2 to the power x times 3 to the power 3x, or we can factor the power x, and we will get that a is equal to 2 times 3 to the power 3, all of it in the power x. And by doing some simple calculations between the brackets, we will find that a is of the form 54 to the power x, where x is a number from the set of natural numbers. So the equation 3 proves that indeed a is a power of 54, which is what we wanted to prove in this problem. So please let me know what do you think of the solution of this problem, and if you have thought of any alternative kind of solution. Let me know in the comments, and please If you like, please support our channel by some subscriptions, and hopefully we will see each other in other updates and other uploads. Thank you for your time, and goodbye.